Given a sequence a1, a2, a3, a4, ... we have a convenient notation that we use when we want to express the fact that we're adding together consecutive terms. It's called summation notation. So for example, let's say we wanted to add together a sub 1 plus a sub 2 plus a sub 3. Here's what we write. That this is equal to, we use a uppercase, what's called a sigma, a Greek letter, the Greek S, sigma, and we write this. I is equal to 1, starts at 1 and ends at 3 of a sub I. So the I, this letter there, it's called the index of summation. And in this case, I can see that the index starts at 1, that's the lower number here, and it ends at 3. So what you do is you for each number starting here and ending there, you plug it in right there. So for example, I start at 1 and I put in a sub 1. Then I go to 2 and I get a sub 2. Then I finally get to 3 and I get a sub 3. And the sigma, that's the letter we use to denote addition, or S for sum. So summation notation. And so basically, this big sigma tells you, let's see if I can write that again. The sigma tells you that you're adding. So the sigma means add. And you start at this number for the index and you end there, and then you add together the corresponding terms of the sequence. So as another example, let's say that somebody wrote this out. The sum from j equals 2 to 5. And it doesn't matter what letter you use here. I used I in the first example and then j here. And the reason is because the letter never explicitly shows up when you actually write the summation out. So let's say you wanted this. The sum of the terms aj as j goes from 2 to 5. So what you start at 2, right? So first you're going to have a sub 2, but then you scroll all the way up until you get to 5. So I plug in 2, then I plug in 3, so I add that to a sub 3, a sub 4, and then I finally stop at a sub 5 because that was the top number here above the summation notation. All right, let's go ahead and see some examples of finding sums where the sums have been written in summation or sigma notation. People use those terms interchangeably. Okay. So let's find the sum. The sum as k goes from 2 to 5 of 1 over k. So writing these terms out, I'm going to have, let's see, first I start at 2, right? So it's going to be 1/2, but then I end at when k gets to 5. So I go k equals 3, so 1/3, k goes to 4, and then I end at 5. So it's finally 1/5 is my last one there. So when I add those all together, I end up getting the fraction 77 over 60. So that's the value of this sum when I write out all the terms. So summation notation is just a convenient way of expressing a sum. Taking another example, let's say you wanted to find the sum as I goes from 1 to 4 of the expression 3 to the I take away 1. So I'm going to start with, I is going to start at 1 and it's going to end at 4, and each time I'm going to plug it in right here. So it's going to be, well, when I is 1, I get 3 to the first take away 1. And then I'm going to add that to, now I goes up to 2. 3 squared take away 1. So notice that it's the whole expression for every value of I. So next one's going to be 3 cubed take away 1 because I is taking on the value of 3. And then finally I takes on the value of 4. So it's plus 3 to the 4th take away 1. And then when I evaluate these, I get, let's see, 3 take away 1. So it's going to be 2 plus 9 take away 1, or 8, plus 27 take away 1, which is 26, plus 81 take away 1, or 80. And then when I add these all together, let's see, I get 80 plus 10 is 90 plus 26 is 116. So that would be my value of the sum. All right, and there's one last point I want to make about summation notation, and it's that there's a connection between, of course, partial sums and summation notation. And the reason is because remember what a partial sum is from the previous video. The partial sum, the nth partial sum is a sub 1 plus a sub 2 plus a sub 3 all the way to the nth. You add in the nth term of the sequence. And of course, this is a large sum, and that can be expressed using summation notation. So the nth partial sum can be expressed as the sum as I goes from 1 all the way to n of a sub I. So go ahead and look at this closely. If I starts at 1, you get a1, and it goes all the way up until I gets to n. And you add all those terms together, and that's exactly this right-hand side. So this is going to be a really important notation that you're going to be using a lot in calculus. Okay, so I just wanted to put it out there that that partial sums can be expressed conveniently using summation notation. Okay, until next time.